In this video, we will discuss another example of conversion from epsilon NFA to NFA. So this is the epsilon NFA that we have to convert into NFA. As a first step, we need to calculate epsilon closure of all the states. So epsilon closure of A would be ABC because we can move to A, B and C just by consuming epsilon. From state B, we can reach to C. So epsilon closure of B would be C. From state C, we cannot go anywhere by reading epsilon. So epsilon closure of C would be just C. Now for state A, B and C, we have to find out delta dash transition function for all the input alphabets small a, b and c. And as we already know that delta dash transition function is defined as this. Delta dash transition function for state Qi on alphabet symbol AK is given by epsilon closure of delta of epsilon closure of Qi comma AK. Let us find out delta dash transition function for all three states. So first we'll compute it for state A and input alphabet A, that is given by epsilon closure of delta epsilon closure of A comma A. So in this, this is a nested function in fact. So innermost function is computing epsilon closure of A, which we have already shown in table, that is A, B and C, three states. Then we have to apply delta transition function for input alphabet A. So from state A, if we read small a, we are remaining on same state, and there is no transition from state B and C for input alphabet A. So that will remain phi. And now we have to compute epsilon closure of that. That is the outermost function. We already have computed epsilon closure of A, which is ABC. Epsilon closure of phi, that is phi. So the union of all these three would be just A, B and C. Now we will compute delta dash transition function for state A on input B. So that is given by this formula. Epsilon closure is already known. Transition B would lead us to phi from state A, state B on state B, and phi on state C, because there is no transition for input B from state A and C. And now for all these three, we have to compute epsilon closure. So epsilon closure of phi would be phi, and epsilon closure of B is BC. So that would be the next entry in the transition table for NFA. Now we will compute delta dash transition function for state C on input, state A on input C. So that is delta dash AC. Epsilon closure of A already computed, and the delta transition function for input C would be phi, phi and C, and then epsilon closure of that would be just state C. So that entry we have to make into this transition table. We will repeat the same process for state B and state C. So we need to compute delta dash B comma A. So epsilon closure of B is just a BC, and on input A there is no transition from B, so that will be phi, and the epsilon closure of phi would remain phi. So the next entry in table would be phi. For input B, the delta transition function would be B and phi, because B is having a one transition for input B and C does not have any transition for input B. And epsilon closure of B and phi would be BC and phi. So that entry of BC we have to make it into table. Next we have to repeat it for input symbol C. So on input C, there is no transition from state B, so it remains phi, and from state C it remains on state C, and epsilon closure of that would be C itself. So that entry will go to the table of NFA. Same three delta dash transition function we have to apply on state C. So delta dash C comma A would be epsilon closure of C, which is C. Then on input A, it will give phi, and the epsilon closure of phi would be phi. So that entry we are doing here. Next we have to compute delta dash C comma B. So epsilon closure of C is C. There is no transition for input B from state C, so that delta dash function would be phi, and epsilon closure of phi would be phi. So again this entry would also be phi, and then we have to compute it for input C. So delta function for C would be C, because there is an arc or a transition from state C on input C, and which is remaining on state C, and the epsilon closure of state C is just a C. So this is the complete transition table. we have computed delta dash transition function for all three states. Okay? And now we will stop, and for this particular transition table we will derive the NFA. So this is the final NFA for given epsilon NFA. As you can see, there is no epsilon and it is an NFA, and both epsilon NFA and NFA produces same set of strings, so they both are identical. Thank you. That's it for today, folks. See you in next video. If you think this video was useful to you, then please like, comment and share. Don't forget to subscribe the channel CodeCrucks. Press the bell icon for the notification of latest videos. Stay connected, stay tuned. Thanks for watching. Bye-bye.